Welcome to class today, geometry students. Hope you guys are having a good day. Hope you're ready to learn some math today. Let's take a look at some quick announcements here. While I'm rambling on, get out your notes, your notebooks, your pens, pencils, calculators, books, and be ready to take some notes. We'll talk about a lot of stuff here. First of all, we're going to have a test next week. I'm pretty sure, don't hold me to that, but we really need to have one. Next week will be the third week of school. We need to get one in so we get at least 3 for the 9 weeks, and I'm pretty sure we'll be able to accomplish that. So look for a test next week, I'm sure, with a lot of excitement in your minds, I'm sure, but test next week. Turn in last night's homework. Now the reason I have Azu's name right here is Azu, you already turned it in yesterday, you know that, so you're good, don't worry about it. But everybody else needs to turn in last night's homework. It was the assignment you did hopefully in class yesterday, and I don't want you guys getting too spoiled with notes on one day and homework the next day. But when it's a lesson that I feel is long and you really need to get it drilled into your heads, I don't want to jump to new material until I'm sure you've understood the material. That's why I've done that a lot lately. So anyways, yesterday, let me grab a quick drink here. Yesterday, I gave you a video and an assignment to work on. It should be done. Now, if there were any problems with finishing it because of church last night, then turn it in and I'll give you a 100. Just write me a note up top. Mr. Earhart, I could not finish because of church. No problem. I believe that you guys need to follow the rules at Berean, and I believe that teachers also have to follow the rules. And so the handbook, as far as I know, says no homework on Wednesday night. So if you did not finish it for that reason, then write a note up top. And then look at this. Everyone's incompletes are turned in. So Martin and JC, you guys were a little behind. You got all caught up. Really proud of you guys. Thanks for doing that. And that means everyone who is caught up at the point of taking the quiz gets 5 bonus points on their quiz. So everybody will get 5 bonus points on their quiz. So a manly smiley face there. All right, now your quizzes are graded and they're on Sycamore. I could not pass them out to you because Haley's not taking the quiz. Now, Haley, I know it wasn't your fault. The teacher did not have the quiz for you yesterday. What I have done is I have emailed Mr. Harmon. I have found out who the teacher is going to be today, and they should have the quiz already. In fact, you've probably already taken it before you started watching this video. So if you haven't, you might want to pause the video now and ask your teacher, where is my quiz? Because I do want that quiz taken today so that I can pass out the quizzes to everyone else. But if you want to know what you made on the quiz, then be sure and go on to Sycamore and look. My voice is a little raspy, so we got a little flu bug and stuff going around the house. So if my son's there today, he's fine. I'm not talking about him, but my younger kids have been a little sick, so maybe I'm picking up on some of that. But anyways, there's the announcements. Call or email if you have any questions at all. And let's go ahead and get started. Here we go. Grab your notebooks, pens, pencils, calculators, all the things that you need. I am going to teach for a long time today, so if you don't finish the video in class, you are responsible to finish it tonight. I am not giving you homework tonight. The homework will be tomorrow. So tomorrow in class, you will work on it. If you don't finish it, you will finish it over the weekend and turn it in on Monday. Again, another important lesson. Do not get spoiled or used to this. But I feel like these are concepts that are a little difficult to understand, and I wanted to make sure we're really getting these, okay? So with that in mind, let's go ahead and get started. Let me grab another drink here while you're copying this down. Let me remind you again of my philosophy. You cannot speed up a video, but you can always slow it down by pausing it or rewinding it. So I am going to go fast, and you'll have to pause the video a lot to write things down. Okay, we're going to look today at proving triangles similar by 2 methods: the side, side, side method and the side, angle, side method. Okay? Now don't forget, we've learned how to prove triangles congruent, and that was what? Side, angle, side, 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 angle, angle, side, angle, side, angle, hypotenuse, leg. These were 5 ways we learned to prove that triangles are, listen, not similar, but congruent, okay? But remember, this chapter is not about congruent polygons or congruent triangles. It's about similar polygons, similar triangles. So we're learning two ways today to prove, to prove that triangles are not similar or not congruent, but similar, okay? Now, lesson 7.4, and if you want to write the date down, today is the 16th. Now, moving on. Remember, we already learned one way to prove that triangles are similar, and it was called the angle postulate. Okay? Remember, if I have a triangle like this and a triangle like this, and this angle here is marked congruent to this angle, and this angle here is marked congruent to this angle. If you have two angles in one triangle congruent to two angles in another triangle, then you know for sure that these two triangles are similar. We learned that yesterday. So we already know one way. So when today's class period is over, we're going to know three ways to prove that triangles are not congruent but similar. Everybody getting this? Okay? The AA method, the side method, and the side angle side method. All right, so today we're going to learn two other ways to prove that triangles are similar. Go ahead and copy this in your notes. You'll probably have to pause the video. But side-by-side similarity theorem, if the corresponding sides of two triangles are, ooh, look, not congruent, but proportional, then the triangles are similar. Let's go over this again. If the corresponding sides, that's all three sides, if all three sides in one triangle are proportional to all three sides in the other triangle, then the two triangles are similar. All right, so let's get a picture of this. All right, now take a look at these two triangles, and I would encourage you to write these in your notes. Now, notice that I know the three lengths of the three sides of this triangle. Notice that I know the three lengths of the three sides in this triangle, okay? Let's check and see if these three sides are proportional to these three sides over here. Now you're like, Mr. Earhart, I don't know which side corresponds to which side. Well, sure you do. Whatever the smallest side is over here, which is 6, that's going to correspond with the smallest side over here, 3. So let's see if these sides are proportional. I'm going to put 6 over 3, okay? And the next biggest side over here is 8, and the next biggest side over here is 4. So 8 corresponds to 4, so 8 over 4. And then my longest side, 10, corresponds to my longest side over here, which is 5. So 10 over 5. Now let's reduce all three of these fractions and see if we get the same number. 6 over 3 is 2. 8 over 4 is 2. Now if you put 2 over 1, that's totally fine. I don't care, that's fine. And 10 over 5 is 2. Look at this. They all reduce to the same number. So I have a question for you. Are these three sides here proportional to the corresponding sides over here? Yes, they are. So because of that, because these three sides are proportional to their corresponding three sides over here, then these two triangles are similar. And thus we've used the side similarity theorem. So that's what this theorem is saying. Do you see it okay? If these three sides are proportional to these three sides over here, then you know for sure that the two triangles are similar. Okay? All right, let's look at the second method. I'm going to grab a drink here while you're starting to copy this down. This is called the side angle side similarity theorem. And it reads, if one angle of one triangle is, not proportional, congruent. When you're dealing with angles, remember students, in similar polygons, sides are proportional, angles always have to be what? You remember? Congruent. Don't forget that, okay? So, if one angle of one triangle is congruent to one angle of a second triangle, and listen, the lengths of the sides that include these angles are proportional, then the triangles are similar. Now look, I'm not asking you to stand up and teach the class. I know this sounds a little bit like gibberish, but in a second I'm going to give you a picture of this, like this, and we're going to talk about it, okay? So let me read this again, then we'll get into it a little more in depth with pictures. If one angle of one triangle is congruent to one angle of another triangle, and the lengths of the sides that include these angles are proportional, then the triangles are similar. Let me give you a picture of what this is saying, okay? Go ahead and copy these triangles in your notes. Now let's take a look at these two triangles. Notice the theorem, first of all, up here is called the side angle side similarity theorem. Side angle side. That means you have to have a side and a side, and the angle has to connect those two sides. It has to be right in the middle of those two sides. In other words, if you had something like this, if you had a side, pretend your angle was over here like 20 degrees. Well, that's not side angle side, that's side side angle. That's not going to work. In order to use this theorem right here, the side angle side theorem, and look how funny this is. SAS, what's right in the middle of the two sides? A, your angle. So just by this wording or these letters right here, it tells you the angle has to be in the middle of these two sides. So notice how the angle is in the middle of these two sides. So I have side, angle, side, and over here I have side, angle, side. So I definitely have a situation here where I might be able to use side, angle, side. Now watch this. Watch carefully. What do I need? Well, first of all, I need the angle. Look at this. I need the angle to be what? Congruent. So are these two angles here congruent? Yes. So far so good. Next, I need the corresponding sides to be proportional. So let's see what happens. The smallest side over here is 4. The smallest side over here is 6. So 4 over 6 equals 6 over 9. Let's reduce both of these fractions and we get 2/3 equals 2/3. So yes, the two sides over here are proportional to the corresponding two sides over here. And the included angle, the angle in the middle of those two sides, is congruent. So yes, we know for sure that these two triangles are what? Similar by what theorem? The side angle side similarity theorem. So that's what this theorem is saying. I hope this picture makes some sense and explains it a little bit, okay? If you gotta back up the video and listen to it again, I feel bad for you, but do what you have to do to really understand this, all right? Let's continue on. We're going to work a bunch of problems now. Go ahead and copy this in your notes. We're going to work a bunch of problems now in which sometimes the triangles will be similar and sometimes they won't be. So let's get started. Here's the first problem of the class period. Determine if these two triangles are similar. Defend your answer. Now the two methods we've learned to use, or three methods, are we learned angle method. That was yesterday. Today we've learned the side method, and we've learned the side angle side method. Now notice something. I don't know any angles over here, and I don't know any angles over here, and there's nothing marked congruent like this or something. So it's obvious the only way I can attempt to prove that these two triangles are similar is if I use the side postulate or theorem. I can't use the other two. They include angles, and I don't have any angles over here. Do y'all see that? So let's see if these two triangles are similar. Okay, smallest side here over the smallest side here. So we have 8 over 4. Now the next size would be, the next longest side would be 10, and the next one over here would be 5. So we would have 10 over 5. And then lastly, 12 over 6. Well, if you reduce all of those, you get 2, 2. I think this is the same problem we did before, isn't it? I am such a great teacher. I scare myself sometimes. Yep, there it is. Same problem. Well, that's great. I feel really good. No, I guess it's not exactly the same as, I guess the numbers are a little different. But either way, you get out 2 equals 2 equals 2. You get out 3 congruent numbers. So, with that in mind, do we know for sure that these two triangles are similar? Yes. So the answer to this question is yes, they are similar by what reason? Side, 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 similarity, theorem. There you go, you did it. That's it. So yes, those two triangles are similar. How do I know it? Because all three sides over here are proportional to their corresponding three sides over here. Okay, let's try another one. Go ahead and copy this in your notes, please. Determine if these two triangles are similar. Defend your answer. Now again, the three methods we've learned, I'm going to cut and paste these so I don't have to keep writing them every time. We have three methods to choose from: angle, angle, side, 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 angle, side. Well, it's not going to be angle, angle because I don't have two angles here and two angles over here. And it's not going to be side, side, side because I don't have three sides here and three sides over here. The only one that maybe I can use is side, angle, side, and that's not even for sure. So first of all, let's see, do I have a side and a side with an angle in between? Yes, I do. Do I have a side and a side with an angle in between? Yes, I do. So I have maybe similar triangles. Let's see. Okay, first of all, my angles have to be congruent, and they are. 61 is congruent to 61. Next, my sides have to be proportional. So the smallest side between the 3 and the 6 is 3, and the smallest side over here is 5. And then the longest side between these two sides is 6, and the longest side over here is 10. Okay, let's reduce both of these fractions. 3/5 is 3/5, and if you reduce 6/10, you get 3/5. So there we go. Yes, these two triangles are similar by what reason? The side, angle, side, similarity, theorem. There we go. So we're really getting pretty good at this. We are proving triangles to be similar, or we're disproving that we're proving they're not similar. In some cases, coming up here, you'll see not all of these are always going to come out similar. Okay? Let's determine if these two triangles are similar. Now remember, I've only learned 3 different ways so far to prove that two triangles are similar. Well, I'm not going to use the AA method. I have no angles. I'm not going to use the side angle side method. I have no angles. I'm going to try to use the side 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 method. So out of these 3 sides, the shortest one is 5. Out of these 3 sides, the shortest one is the 9. The second shortest side is 12, and the second shortest side is 12. We can see right away this isn't going to work. The longest side is 13, and the longest side is 15. Well, if we reduce all of these, 5 9s cannot be reduced. 12 over 12 is 1, or 1 over 1, whatever you want to look at it. And then 13 15s cannot be reduced. Well, students, we've reduced all of these fractions as far as they can go. Are these 3 fractions equal to each other? No, not at all. So are these two triangles similar? No. These two triangles are not similar. Okay? So there we go. Nothing else I can do. I mean, the only way these two triangles are going to be similar is if all 3 sides in this triangle are proportional to their corresponding sides in this triangle. Okay? And that just didn't happen. Did not happen. All right, let me get a drink of water real quick, and we'll continue on. Go ahead and copy this in your notes, please. Determine if these two triangles are similar. Okay, defend your answer. Now, you know Mr. Earhart, I like to split these triangles up. I think it's very helpful to do that, okay? So I'm sorry if that annoys you, and if you don't want to do that in your notes, that's totally fine, okay? But it's something I do try to do. So I'm going to pull the top triangle away, and then I'm going to pull, hopefully, the bigger triangle away. All right, and then also I think it's very important that we label everything. So this is W, V, X, and the big triangle is Y, V, Z. Now, let's write down some lengths or measurements that we know. For example, this little triangle right here, This little triangle up here has a length of 4 and 5. So I'm going to put a 4 here, and I'm going to put a 5 here. And this big triangle has a length of not 4. Look, from here to here is 4. And this whole side is not 8. From here to here is 8. This whole side is 12. Okay? This whole side is 12. And what would this whole side here be? Can you figure it out? That whole side right there would be 15. Now, let's see if we can't prove that these two triangles are congruent. We have 3 methods that we're going to be using, and here they are. We know we can't use angle, angle, there's no angles. We know we can't use side, angle, side, there's no angles. But hold it, we also cannot use side, angle, side, or side, side, side. We don't know all 3 sides. Well, hold on, let's let a little common sense kick in here. Let's think this through. True, I do not know anything about the angles here and here. However, if you go back to the original drawing, do you notice how the little triangle, this angle right here, is the same angle as this angle right here? And the big triangle, this big triangle right here that goes all the way around like that, do you notice how this angle right here is the same as this angle here? So what that tells me is simply this. It tells me that this angle right here is congruent to this angle here. Now, do I know the measurement? No, I don't. I do not know the measurement of this angle, but I know they're congruent. So now I might be able to use side, angle, side. Do you remember? For side, angle, side, the only 2 things you have to have, well, 3 things. First of all, you have to have a side and a side with an included angle, and we have that. And you have to have a side and a side with an included angle, and we have that. Secondly, the included angle has to be congruent. Now, I don't know what the measure of this angle is, but I know that this angle here is congruent to this angle here, so that's fine. The other thing you need is the sides, the 2 sides here, have to be proportional to the corresponding 2 sides over here. Let's see if that happens. 4 and 12 are the 2 smallest sides from each triangle, so 4 would go with 12, and 5 would go with 15. 5 over 15. Now reduce each one, and you get 1/3 equals 1/3. Hey, it worked. So, are these 2 angles right here, this angle and this angle, are they congruent? Yes. Are these 2 sides here proportional to their corresponding 2 sides over here? Well, yes, we got out 1/3 and 1/3. So there we go. Yes, triangles are similar by side, angle, side. I'm not sure why I put SAA. Side, angle, side. Okay? That's a pretty good one there. You had to think about that one, so that was good for you. And I believe, if I remember what the next problem is, this is a pretty tough one too. Yeah, this is it. Okay. Now, go ahead and copy this in your notes. And I'm not sure why I didn't put, I'm going to fix it right now while you guys are copying that down. Hold on 1 second, please. Thank you. All right, go ahead and copy this in your notes, if you would, while I'm kind of fixing this thing up here. Here we go. All right. So we're going to determine if these 2 triangles are similar. Defend your answer. All right, no problem. Here we go. We've done this quite a few times today. I like to separate my 2 triangles. That's just me. So I'm going to pull this down here. Okay, let's go ahead and label this little triangle here would be triangle HGJ. This triangle right here would be GKJ. And let's see, this length right here is 24. But notice how this length right here, students, is the exact same length as this side here and this side here. These 2 triangles shared that common side. Remember, this triangle right here was right up against that triangle right there, okay? So I know also that this side right here is 24. Look at this. I know I've got a measurement of 10 here, and I know I have a measurement of 32 here. I know that I have a right angle here. Look at that. And I know that I have a right angle here. Boy, now that I've pulled these two triangles apart, that really helps a lot, doesn't it? I think it does. I mean, I've got a lot I can deal with now. In fact, I'm going to go ahead and pull this off to the side. I really don't need it. Now, look at this. I'm either going to use angle, angle, side, 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 or side, angle, side. Isn't it obvious which one I'm going to use, students? Come on, it should be. Side, angle, side. It's not going to be side, side, side. I don't know three sides. It's not going to be angle, angle. I don't know two angles in this triangle and two angles in this triangle. But I can use side, angle, side. Now, there's three things that we have to check to make sure we can use side, to make sure that side, angle, side works. First of all, do I have a side and an included angle? Yes. Do I have a side and included angle? Yes. So that's good. Number two, are the included angles congruent? Well, this is a 90-degree angle and this is a 90-degree angle. So are they congruent? Yes. Next, we need to see if the sides are proportional. So we take the smallest side over here, which is 10, and the smallest side over here, which is 24. 10 over 24. And then we take the largest side over here, which is 24, and we put it over the largest side over here, which is 32. And you're going to see we do not have similar triangles. If you reduce this fraction here, you will get 5/12. If you reduce this fraction here, let's see, a goes into both of these 3 times and 4 times. This fraction is reduced as low as it goes. This one is reduced as low as it goes. And do we have congruent, or not congruent, do we have equal fractions? No, we do not. So, were the two included angles congruent? Yes, they were. However, are these two sides here proportional to their corresponding two sides over here? No, they are not. No, because look what we got out. We got out 5/12 and 3/4. So, no, the triangles are not similar. No. Okay? All right, let's continue on. Back this up and pause this as much as you need to, okay? I'm going to grab a drink of hot water here while we're moving on. Okay, go ahead and copy this down if you want to. And I don't think, I'm usually a pretty prepared teacher, I do believe, but I don't think I wanted all of this in here. It's not the end of the world that you see this, but this is all together, isn't it? Okay, that's fine. Yes, in case you're wondering, I'm talking to myself. All right, let's go ahead and cross this off, cross this off. You never saw this, okay? All right, very good. Now, let's see what the question is. Go ahead and copy these triangles in your notes, would you please? And let's see if we can't answer these questions. Is either triangle DEF or triangle GHJ similar to ABC? Well, students, there's only one way to find out, and that's to check it one problem at a time. So let's first of all see if this triangle here is similar to this triangle here. So just for a little bit, we're going to ignore this, okay? Just forget that triangle's even there. All right, is triangle DEF similar to ABC? Well, let's find out. The only method we're going to be able to use is obviously the side, side, side method, because we know all three sides of all three triangles. So here's DEF right here. We're dealing with this triangle here, and we're dealing with this triangle right here, these two triangles. So here we go. What is the smallest side in this triangle? 6. What's the smallest side over here? 4. What's the second smallest side in ABC? 9. What's the second smallest side over here? 6. What's the longest side over here? 12. And what's the longest side over here? 8. Let's reduce these three fractions. 6 over 4 reduces to 3 over 2. 9 over 6 reduces to 3 over 2. And 12 over 8 reduces to 3 over 2. So there we go. Look at that. All three sides in this triangle are what's the word? Proportional to all three sides over here in this triangle. Okay? So, when that happens, based on the side, side, side similarity theorem, I can state right here that triangle DEF EF is similar to triangle ABC. All right, so let's go ahead and erase this. And now let's try the other two triangles. Cross this off. Now let's see, is triangle GHJ similar to ABC? Well, let's see. Now we're dealing with this triangle here and this triangle over here. Let's see if they're similar. Here we go. And I should have put a little more here in my answer. These two triangles are similar by what reason? By the side similarity theorem. Okay, we're comparing this triangle and this triangle. The shortest side over here is 6, and that would correspond with the shortest side over here, which is 6. The next shortest side, or the second longest side, is 9, and the second longest side over here is 10. So 9, we can already see it's not going to work. 9/10, and the longest side is 12, the longest side is 14, so 12 over 14. So if we reduce all of these, 6 over 6 is 1 over 1, or just 1. 9/10 cannot be reduced, so we leave it 9/10, and 12/14 can be reduced to 6/7. So no way. All three, not just two, all three of these fractions have to be equal, congruent or equal. And if they're not, then there's no way that you can state that these two triangles here are similar, or these two triangles right here. So triangle ABC and triangle GHJ are not similar. So I would write something like this. Triangle GHJ, now watch what I write, please, is not, put a slash through it, is not similar to triangle ABC. Why? Because the side theorem failed. It failed, and so there's no way that these two triangles are similar. Okay? Okay, let's go ahead and take a look at your homework. I know you don't have to work on it tonight if you don't want to, but I think you can see now how long these videos are. I'm really trying to give you tons of examples and excuse me, sorry, and drill this stuff into your heads, okay? And then give you time in class tomorrow to work on your homework. So here is your homework assignment that you're going to work on in class tomorrow. If you want to get a head start, let's see, tomorrow there's a basketball game. So maybe some of you want to go to the game. And so you want to get a jump on your homework tonight. I'm sorry, I'm thinking ahead. I'm doing the video a day before. You're on Thursday night. Tonight there's a game. So you might want to get a jump on this now. It's up to you. Just get a head start on it. But this is not due tomorrow. You're going to work on this in class tomorrow on Friday, and it's due on Monday. The assignment is page 382, numbers 5 through 13, all, and then 15 through 26, all. Also, you're going to copy each one of your theorems 3 times each. Now the video that you're going to watch, and by the way, it's not posted yet. Do you remember the problem I had with the homework video last week on Friday, I think it was? Well, because that happened, I'm checking these a little more thoroughly, and I was checking this earlier, the one from last year, and it was, I'm not so sure it was working. So this video is not yet posted. It will be posted by tomorrow morning, Friday morning, so you can have it in class. But you can still start working on this if you want to. That's up to you, okay? So this is your homework, all of this. It's due on Monday, and you're going to work on it in class tomorrow, or yeah, in class tomorrow on Friday. Hopefully I've not confused you. I hope you guys have a great day today. And if you have any questions, call me or email me. And again, Haley, make sure that quiz is taken today. And then lastly, I think that's all. Your quizzes are graded, and they're at Sycamore if you want to see how you did. And hopefully I'll be able to pass those back out to you on Friday. Okay? Have a good day, and we'll talk to you later.